Japan market. Also sometimes I support for the Korea market for the VNAs. So today's maybe it's a demonstration how to make the noise figure by Mr. Christopher. But I will try to explain some like number is the noise figure measurement directly in the future a little bit, and so that is my outline on the board background for the noise figure measurement. Maybe that you already know the what is a noise figure measurement method. Currently, there are two methods in the market. One is a Y factor. It's technique. That is using the noise source, hot and cold noise source. So need an external noise source. And for the cold source, does not use the noise source. Only use cold source module. That is like a termination. We are recommendation. So sometimes the cold source mode method is easier than the Y factor method. Easy calibration, and only one source, no any power supply for changing the hot and cold noise. That is some like a formula is maybe this one is Y factor is method using the hot noise and cold noise. Then calculate it to the difference of the source, cold noise, and hot noise. So if they're using this method, for the noise source is like some is calibration factor, excess noise ratio, value is very important. So if so customer have to calibrate yearly at some calibration level. But that kind of the calibration is very difficult. So it can available for limited calibration metrology center. So that is like a Y factor measurement method. It's like a noise figure analyzer, and some like a VNA also can use the noise source. So cold source method is this. Simply is the diagram here. Using the network analyzer, sometimes it's a spectrum analyzer also is used. And it's the noise source is like here. It's termination. Then can measure only one noise source. Source is generator, and measure the noise. But for this method, need some, we call it composite receiver. So outside of the preamplifier and a filter needed. This filter is the rejection to the illegal signal like a spurious of the local generator. Because that's kind of the VNA or the spectrum analyzer to down convert to measure any signal internally. So that is some the local generator to get some like imaging. Then sometimes to applying any illegal signal to the IR port. Then there is the eliminate such kind of the spurious by the external bypass or low pass. this system for the measure is the DUT noise figure. First, we have to calibrate the composite receiver side. Noise is absolute noise power measurement is the accuracy by using the sunlight source. So sometimes such kind of the calculation is very important to keeping an accuracy. Then after finished, some is the composite receiver is calibration, and then is the calibrate for the noise calibration of the total system's noise. Then there is the then after this the takes the noise calibration data, then put in a DUT between here. Then measure the difference of the receiver noise and the DUT noise. Then calculate it to the noise here. And also, that calculation need DUT gain. So this is cold source method noise figure measurement. First is the first I have to measure is DUT is parameter first. Then it's a load, that's kind of this parameter data to the VNA, and I calculate it with the noise figure. So this is like a filter is the choice for the composite receiver side. The things depend on the frequency band and some is frequency. So what we can provide how to calculate to the filters is the low end and the high end frequency. This is receiver calibration is configuration. This is using the VNA's output signal, but it's low power around minus 50 dBm or minus 60 dBm. And some case, if they are using the long cable or some other is the transmission path, then in that case, at this point, its power level is not so flat over the frequency. In that case, we have to power is flat power calibration using the external power meter at this point. Then after finish that is power calibration, then calibrate for the receiver. Then we can get more accurate is the noise measurement. But the usual case is that kind of the cable not so long and not so is the wide band. Then maybe is the test spot areas is power is not so big change and not it's almost is flat. Then maybe no need to any that kind of the power calculation. I already said that how to calibrate the noise of the receiver using only a termination linked to the composite receiver input side. Then the measure is kind of the absolute noise power at this time. Then after finished is the receiver noise, then put in a DUT and terminated by the termination input side of the DUT. Then we can calculate the noise figure. This is like some comparison for the similar type of the measurement methods. That is some scalar type of measurement, vector type of measurement, and now it's full source mode. It's almost like a same result for the sunlight frequency range. No so big change. You see the in our 1 dB here, 0.2 dB per division. And for the millimeter wave is the areas is here is measurement. Now it's shown already explained for the time period. It's unlit can offer the millimeter wave noise figure measurement by using the power source. So we will just introduce the such kind of this module. This one is the same as S parameter, same as 3743 is millimeter wave S parameter module. But this one is only for the receiver. No any coupler inside of the module. Let's show you this one. I can show you the what is different. The standard is the transmission and the reflection module and the receiver only module. This is like a block diagram of this module, standard module. So this module to get the through pass from the VNA up to the 54 gigahertz signal, and through to the 1 millimeter connectors. And have the two multiplier for generate millimeter wave signal is over 54 gigahertz. Then I have to combine two and out to the 1 millimeter connector. And this is module have the dual is copper inside of the module. See this is a dual coupler to using the one is the pick up the reference signal from this line and down convert to the IF signal and back to the VNA reference input. The other is like a coupler to measure input signal from the test board and down convert and back to the test sampler to the VNA. So this is a standard module. That is important for the S parameter measurements.
Yeah, excuse me. So there are two additional high frequency signal generator built in this module.
Signal generator.
But signal source, I mean the 54 to 80 and the 80
Here.
to 110.
Yeah. So this is like a multiplier. Okay, so VNA, from the VNA, this is RF output to come through from the test cell and apply to here. Then multiply at here. Then generate the 54 to 80 gigahertz signal.
So how do you generate the error source for the multiplier
Here?
from the button test set or the additional?
No, it's a local signal also generated in this VNA.
Oh, okay.
Because in standard VNA, you have the two synthesizers. One is for the RF signal. One is for the local signal. So for the millimeter wave is measurement, we will use inside of the two signal generators of VNA. So no need to be any external source. And this one is a receiver only module. So eliminate any multiplier and directional coupler. Just only a receiver. So we can eliminate that kind of the directional couplers. The directional coupler have some insertion loss, coupling loss. It's about 16 dB. But now if we cut that directional coupler, then we can expand the dynamic range. So then I keep some good dynamic range for the noise figure measurement. So as a company, this millimeter wave module, same configuration as the our module. So if they want to measure noise figure using such kind of the module, they have to keep the dynamic range because then I have this loss, coupler loss. This is it's the local multiple is the some is the limitation of the cold source modules. Could not make them very broadband measurement. Have the some frequency range the limitation because on some like the multiply number of the local signal generator. So it's the that is a multiply number a little bit different than the frequency range. So we could not make measurement from 54 to 110, something like that. We have to divide the two frequency range, and also we have to select some narrower bandwidth of the frequency because some limitation of the bandpass filter. So it's about 5 GHz, 6 GHz bandwidth is maybe okay. But wider range is a little bit difficult to use the bandpass filter. And the measurement is procedure is like the same as the standard coaxial systems. I need external is the composite receiver that here. Now we are constructed to the two amplifier, pre-amplifier, one bandpass filter. And now we are adding the isolator to improve the match, impedance mismatch of the composite receiver. This is something like that. I explain this very, very briefly for the cold source method, and now it's millimeter wave noise figure measurement solution. So if you have any question, then we can try to answer to your question. And if no question, Christopher is the demonstrate to you how to make measurement of the noise figure. So today, the first we're displaying it. Oh, okay.
Actually, I have a question about the bandpass filter. You say the best bandwidth of the bandpass filter is 5 to 7 GHz. But if we want to cover full B band or W band, that means we need a lot of bandpass filter and amplifier.
Sure, sure.
Okay.
That is like a cold source method is limitation. That is the same as the other is compact. You know.
So can we find the exact value of the bandwidth or something like that, just experience?
Mm-hmm.
There's a calculation way for the field.
It's very providing some like is the calculation, the formula, microwave regions, and millimeter wave. So that is a calculation to very simply. If you want to measure some of the frequency range, then it's divide by this multiplier number. So 80 to 94 is like 11. So divided by the 11. Then is the multiply to the 10 and 12. Then it's find out the it's a filter bandwidth. At here is low end and a high end at here. So if this is bandwidth too wide, then that is the frequency is the range of the filter cutoff frequency range is not meet to this measurement range. So you have to decide that kind of the calculation and find out the bandwidth.
So in this case, we can calculate the most bigger range twice.
Twice, yes.
Design engineer. Right now it's in USA and his office. If you ask very tough question, I send email, he answer right away. So we are here also to help.
Because sometimes we will design some maybe amplifier or mixer receiver to cover for B band, W band. So sometimes we need measure the noise figure, maybe cover for B band or W band. So I'm wondering, can I just pick a bandpass filter maybe from 80 to 110 gigahertz? Yeah. Or what will gonna happen? Maybe some problem or other. Yeah. I'm not sure. Can we use more wider families to measure noise figure? It's very important for us because I don't think we have a lot of money to support such many bandpass filters. And I think amplifier is more easy because broadband amplifiers can use anytime. But yeah, actually bandpass filter is really a big issue.
I think the preamplifier is can use the full band, but you have to change the filter.
Yeah.
Because I know that if you are developing the broadband amplifier and wants to measure the noise community, that sometimes there are some problem. We understand. But that is like some like limitation of the local signals, multiplications, and some like image coming up and down to the higher frequency. That is the problem. So anyway, there is the
尽量问没有关系。
讲，但是他是讲说 image 的问题嘛？对，那 image 的 frequency 是在 locate 在哪里？
那现在这个就是怎么样选择 filter？你的待测键如果是88到94的话，怎么样计算你要用 filter？所以刚才讲在88到94这一段的话，要用这个11这个 multiplier， 所以这里除以11等于8，这个待测键的频率94的话，除以11等于8.5，再从这边除以10，乘以10乘以12，得到了这样子两频段。那你的 filters 就必须要选择在这个频段，所以这是一个计算方式，是选择 filter 计算方式。所以我们现在今天的展示是一个88到93 GHz 的 amplifier， 用这样的方式的话，得到的也是可以得到一个 filter， 一个载带的 filter 的频段。根据你说可不可以用跟 wideband filter，wideband filter 的话，会造成有 image 的信号，也会打到这个 receiver 的这个里面，造成你的讯号收取到的信号不光是你的待测键的信号而已，所以会影响你的测试。所以你们如果说是测试一个 wideband 的话，等于说要分几个频段。比方说，你的待测键是60到95的话，那你可能要分几个段来选。你要把60到80这一段来选一个 filter， 然后测60到80这一段的 noise figure， 然后再测80到95这一段来选。
所以我的问题是说，那就是说那个 image frequency 在你 multiplier 是同样一个乘数的情况下，那是不是就可以用同一个 filter？ 比如说80到100就用一个，我算出来一个我就用一个这样，然后54到80就用一个，然后剩下的就再用其他的方式。是跟因为它是跟你的那个 image 的频率有关嘛。那今天如果你 cover 进来你那个频率，你跟它的第二个把那个 image 给 cover 进来，那它势必就noise speed 会算到就是比其他原本单纯的讯号。所以我想要知道的是说，那如果就是我如何去知道说那个 image 它的频率是在哪里？然后譬如说在multiplier 乘以11的时候，它的频率在哪里？然后我可以去选一个就是避开它的最大的范围内，我可以都把 image 避开的那个 band path 这样。
我现在立刻问一下我们工程师说，以他的经验的话有什么建议？那我们继续，你有下一个问题的话，我们继续请书记上做说明。我立刻发问。Alex John right now. He's asking between, for example, this 1 measure 80 to 110. Can you choose one filter from 80 to 100? But if there's an image, how to calculate the image?
I calculated before the 80 to the 110 years. Calculate. It's the using this method. Then so it's the that is the field is bandpass filters is do not meet to this frequency range.
Yeah. So it means the widest bandwidth of this measurement just start from 87.27 to 100 gigahertz. So from 100 to 110, I need another filter to cover.
Yeah.
How about the specification of the bandpass filter? Specification of the filter.
It's the sometimes rejection of the this is a frequency. It's maybe it's about 15 dB. It's rejection at band is H frequency.
15 dB.
15 dB.
So, 15 dB.
Sorry, it's band is rejection areas is over the 15 dB is maybe is enough. So not so high rejection. No need that high rejection.
Then how about the slope? Because you mean 50 dB, maybe maybe after 3 gigahertz, maybe after 10 gigahertz.
So usually you said this the bandpass filter is bandwidth is like 3 dB down here. So here is the some like a low end and the high end frequency. So yeah, need to the is about 15 to 20 dB. Is the rejection of the any like image. If they have that kind of similar at here, then we can reject the 20 dB maybe now. So yes, it's a question is very important. That is the slope, how to make it.
Yeah.
So that is like depend on where is like a image signal is coming out to the outbound of the filter.
Here comes another problem. How can I know where is the image?
Sure.
Yeah.
Because we have to determine how to select the bandpass filter.
It's maybe it's we can calculate for the such kind of the image signal which frequency to the depend on the local frequency and the it's a multiplier number and some like inside of the it's VNA is inside of the some like it's mixer is the structure. So that is like a little complex. So I cannot say now it's the how to calculate, but that is like important thing. So how to calibrate the image is the signal frequency at any band. So maybe some like image is the image local frequency at the and some is image in like the same space is coming out. So if we are automatic noise that kind of it's still complex for sure.
And we also have another question.
Can we include the image together and integrated by every？我讲中文啊，就是假如说 我们现在就直接干脆把image纳进来，然后之后再用数学把它校掉，就找一个很宽的纠正。然后因为我们做single tone嘛，然后image 跟整体反应都是一样的东西，那可不可以直接把它消掉这样？ They want to buy a broadband filter and include the image frequency, and they want to calculate to kill the image frequency response. Yeah, because the signal and the image is the same. We just do the continuous wave testing. So can we kill the image directly by calculation? I think maybe after the noise calibration, our DU at first we will measure our DUT's S parameter.
Yeah.
So we have our shape, maybe an M5.
Okay.
Yeah. And here is our desired band.
Okay.
And image is located here.
Yeah.
But we also have this S parameter at this frequency. So can we just use a full band Phantom filter and include the image and the desired signal in. And finally, we will use this S parameter to calibrate this image out. Can we use this method? Or
That is one idea, but currently where is the recommending to use the hardware detection image. But that is like maybe some like a solution. So I have to ask to the our engineering group.
Yeah, I just sent a question to engineer. Yeah, so maybe in a few minutes we will get the answer.
叠进去啊，档子都进去。
我们这个的方式。
可是那你如果是右边的话，那个就进去了。你说量到右边。
那这样子就是你只要S3原本都到自己都我觉得应该会有一定程度。
我觉得会叠上来，或者比较差。3dB 是2边一样大，但是你现在频率响应不是一样大。
但是我们有频率响应啊，
可以直接这样挡开来。
因为如果就要看它可不可以 K 到哪里，如果它整段后面你只能全部都 K 掉的话，那我们前面就只剩下 noise 跟我们。
那你怎么知道它 L sample 多少？这中间的 F 等于是多少
？L 中间的 F 等于。
不，你指了 L 进去后，你就知道 image 就可以直接放，假设2个 S 参数。可是你怎么知道说它 F 它 L 只有给你挡下来
？How to measure the mixer's noise peak?
That is currently we have not no any user interface in a VNA. So is the
Hello?
We can do that.
Hello, John?
We can do that, but
Yeah.
have to set some like this measurement condition by yourself
Hold on a second.
to the network analyzer. Some like mixer is the frequency is the like cables.
John is on the line. Hi, John. Can you hear me?
Yes.
Yeah. Thank you. We just got a question from the Taiwan University they asking right now. They want to measure a broadband CMOS or gallium arsenide device for wafer noise figure measurement, and they are wondering to save their budget. They use a broadband filter, for example, 80 to 110. Based on our filter selection guide, the multiplier factor is 11. So their question mainly is, can they save the cost to select a filter to cover the whole 80 to 110 gigahertz to construct their composite receiver? And also they are asking how to calculate to get the image signal frequency. Can they mathematically remove the image signal through their software and still can get a reasonable noise figure measurement result? What's your thought on that?
Unfortunately, a single filter wouldn't be able to eliminate the images over that band. As an example, let's take 88 gigahertz. Multiplier is 11, so the base LO is at 8 gigahertz. So the images at 10, 12, the nearest, they would be at 80 and 96. So you need to be able to filter those out. Now to answer the second question, in principle, yes, you could remove it if the noise under test is sufficiently flat. You might be able to just treat the individual images as adding as equal or as numbers. And you would just subtract off how many images are in band. For example, if there was one image in band and it was an 8 lamp, you could just subtract 3 dB. And as you have more images in band, you subtract a larger number.
Does this answer your question? So basically, Dr. John Martin mentioned, for example, the 88 gigahertz using multiplier 11 divided by 11 is 8. So the image frequency is at 80 because times 10 and times 12 is 96. So you know the image frequency is at 80 and 96 in this example. And also for your amplifier, 94 gigahertz on the top, its image is at 85 and 102. So if you have a way to mathematically remove those power, and he said still doable. But you need to have a DUT has a quite flat response, right, John?
Yes. In that way you can treat all the image responses as being equal and correct accordingly. If it's not flat enough, then obviously that doesn't work very well.
When you say flat around enough, it's about the 1-2 dB of fluctuation in the trace, or
Well, it's flatness in noise power contributed that's important. So it sort of implies both the gain is flat to within a dB or so of the noise figures.
so in noise figures trace 在1 dB 的这个 variation， 像这么平坦的这个 device 的 noise figure 曲线的话，你可以用宽频的 pass， 然后用数学方式 remove 掉那些 images。Okay, so that basically solve our question. Okay, so that's all for now, and we may call you later again if required. Okay? Yeah. Thank you. Bye bye. Thank you. Basically,
It's okay, mate. You can mask out something. then measure the
It's a very good idea. They said they want to use a transparent. But he said, John Martin said, the device noise figure trace need to be within 1 dB of flat surface. If it's jumping down, but it's a flat down within 1 dB, they can use this manually remove the images.
你刚刚说那个在 1dB 里面那个
是 noise figure 的 trace，
不是 calibration，
不是 calibration，是 noise figure。
那他们的那个 noise 如果都没那么频繁的话，
那就要找，那就要踩平的了。你找平坦的地方，越宽的 filter 越。
如果实物实在是斜的上去，就是我们比方说一样，就是这样斜斜这样斜上。
没有，他说他 noise figure，那个 noise figure 的 trace， 如果是在 within 1 dB 的这种波动的话，这种的待测键，他说可以用数学方式移除掉 image， 你可以用宽带的 filter， 然后用数学方式移除 image， 那几个 image 的 power。但是如果是波动大于1个 dB 的 noise figure 的话，他就不建议用宽带的 filter。所以你可以先用我们这种方式测试你的待测键。看你的 noise figure 平坦在1个 dB 的是哪些频段，那个整个段都可以用跟它使用。如果是比较波动大于1个 dB 以上的，那就要暂停的 filter， 而不能用数学方式移除。所以它真是 depends on 你的 device 的 noise figure 曲线。用我们这个测了之后，你可以决定你可不可以用宽一点的 filter 对 pass filter。
可是这样变成还是我们还要先有很多个小的 filter 以后，才能知道整个变。
不见得，你如果说用这样一测你的待测键，你如果组装好你的对 pass filter，你可以用宽屏的来做。如果宽屏的一做，它的 trace 一定是蛮平坦的，那表示可以。那如果宽屏的你一测，
其实说那个数值可能不对，但是那个趋势有可能是。
对。刚才江茂好像有提到说可以可以移除的、可以减掉的 power 是每一个 image 是2-3个 dB 这种数值。
就出来的东西有在减。
对
，ideally 是当多少频段？
对。但是你们的设计的 amplifier， 你们的经验是 noise figure 会很频繁吗？在1个 dB 的这种，
就是那些要看设计。
像我们这个待测键就是差不多在1个 dB 以内的。
就是频带都当然是没有问题，可是output就开始说一定会往上小，那个很多用。
那还有问题，那如果是比如说在这个频带内，但是它的 noise figure 不频繁，
那它会有问题。
这样应该没问题，因为没有 image 的问题，所以
对对，
就直接量就好了。
对，直接量。那就是你真实的跟买的 noise figure 的曲线，因为你已经跟 pass 都已经做进去。
Mix NF measurement is we can do, but currently we have the mix NF measurement user interface in a VNA. But we get a measure by manually. First, we will try to make a measurement of the conversion gain. And this is a conversion gain with the extract to the, it's only a text file, not S2P file. Text file is the, save to the text file. Then we have to it's modified to the S2P file. Because it's the noise figure measurement can load S2P file for DUT gain data. So we have to convert here. And for the is the noise figure measurement is like same as the standard noise figure measurement. The frequency is this is IF frequency, so it's very low. Sometimes it's 100 megahertz or something like that. Yeah. So is the you have to construct a composite receiver at the IF frequency. So 400 megahertz or 100 megahertz. Then you can choose the filter is only a low pass filter. So more easier to is construct the composite receiver, I think, because IF it's sometimes not so wide. And it's the measurement is process is the same as the standard noise figure measurement. To calibrate the receiver, then it's calibrate its receiver noise, then I put in a DUT, and then terminate of the input. Input meaning RF port. Then can measure the noise figure. And at that time, you have to input the LO signal to keeping the operation condition of the mixer. That is current is mixer noise figure measurement process.
So which frequency we need to calculate, the R frequency or the I frequency?
It depends on your device. So we no any limitation for the RF input and IF output.
If we have maybe 50 gigahertz output and 1 gigahertz IF output, should we calculate the
50 is the 1 gigahertz.
should we calculate all the input and output from 1 to 50? Cover all of the IF and the R frequency?
Or only I?
Before the noise figure measurement, to generate the TF.
Yeah, that is like a this is meaning is like a gain of the active mixer.
Oh, conversion.
Yeah, conversion gain. Then save to the text file first. Then create a S2P file because we have to load to the calculation of the noise figure.
But the conversion gain
Only magnitude.
only is only
S21.
related to.
One kind of the S21.
So how do we define the S parameter file, S2 file?
It's
we
we
also include the S11, S22.
so we have to make the some like an image file first. Then put in that is like a conversion gain to that image file. Then is the transfer to the S2P file. It's like that's kind of the procedure. We can supply it already. That's kind of the procedure.
So you assume the regional is perfect.
Yes. So also you can create by your simulator, circuit simulator, using the that is the conversion gain, magnitude only data.
So in noise figure measurement of the mixer, it still use the cold source. It still use the cold source measurement.
Cold source. Cold source meaning like a local external source.
External source, internal.
Uh-huh.
Yeah, we only have to inject the LO signal, no R signal.
No, it's RF signal that from the VNA.
Okay.
So we need an external side of the local signal
Okay.
currently.
So for the conversion gain text file, we have to generate by ourselves.
If you is generate by this is conversion gain yourself, then you can try to construct high frequency as a composite receiver and termination. Then you can measure. no need this is measurement, right?
What is the loss is frequency of the ion? Loss is
What is the lowest frequency? What is the lowest frequency of our?
It's the 70 kilohertz.
so the noise figure at 70 kilohertz is reasonable.
It's the reasonableness meaning is
It's accurate. If we use this measurement.
accuracy. So we have to change the accuracy of the 70 kilohertz.
Yeah, it's the same. But
Same.
below 30 gigahertz, the noise figure measurement is done in the instruments, not in here. This receiver starting measure noise figure on 30 gigahertz, 30 to 100 gigahertz. So the accuracy is as accurate as VNA.
Start from 30 gigahertz.
30 gigahertz.
Below 7 gigahertz is measured by
30 giga below 30 giga 以下的 noise figure 是在那个 VNA 主机里面操作的。
So we don't need another filter and amplifier when we measure the noise figure below 30 gigahertz.
还是一样 You still need to make your own capacitive receiver.
就是接在这边这样。
OK.
不过30到70 giga 应该是可以在直接用这来做。
对，30到70就只要不必外，
就是70以上还需要透过
30以上它就从这里直接往那边。
那30以下的 gigahertz 以下的 noise figure， 它那个 filter 也是根据这个落去选。
是一样的，它是同样的。你看，can you move above So this is user guide.
Yes.
User guide.
37 40 years ago.
所以如果在2.5以下，那我们预测当下通常是2，都是1 giga 以下的东西。那如果1 giga 以下需要 filter。
1 giga 以下，2.5 giga 以下是用 low pass filter。
哦 OK。
对。
所以都不用去算变化。
OK， 更多 pass filter 这一些。对，我们还蛮常聊到这种。
但是就是接法可能要注意，就是接在这边。对，2.5 giga 以下。
OK。
接到哪里
B2。
So below 2.5 gigahertz, connect to B2.
Connect to the B2, the front is rear panel.
从背面来。
Yeah. It's a low end.
Not from the front.
No.
B2 also has connect.
Okay.
We are not talking about mixer. Or two-pole device. Noise figure. Below 2.4 gigahertz. 2.5 gigahertz. From back panel.
Yes.
Can we measure
Front loop is the over the 2.5 gigahertz. 2.5 gigahertz is the loop. Where is it?
2.5 giga 以下的 B2 呢是在后面的。那前面面板的 B2 是2.5 giga 以上。
到30。
So here B2 here using for 2.5 to 30 gigahertz.
Is that right? No, 70 gigahertz.
70 gigahertz. So for example, right now this is from 30. And this can cover 30 to 70.
No. This is module convert to the IO frequency at here
I see.
from the 30 gigahertz to the 112.
So up to the 70. This is.
Yeah.
And below the 70. This is.
Suzuki-san,
Yep.
can you teach us? Because their measurement maybe sometimes below 2.5,
I know.
sometimes between 2.5 to 30, sometimes below 2.5 to 70 gigahertz. Which connection they need to connect?
So 2.5 to the 70 gigahertz use this port. Standard this port. test board. Or for the noise finger measurement, using the B2 directing
To 2.5 to 70.
70. And the below 2.5 gigahertz have to use the rear panel.
B2.
So B2. So that's kind of the mixer IF. If the mixer IF frequency below 2.5 gigahertz, have to use the rear panel. It's loop.
这样就可以了。
对啊，他没有进步，他就是一直强调一直是用termination，
这样就可以了。
他好像是一开始先讲，然后你到时候就直接塞上去。有点像是安全它好像是塞一个类似那种 source 的东西，它就是有点是用误收，它是用当 call source 当那个。
安全它是里面有一个那个noise diode source，那个需要之后也需要那个 calibration， 但我们里面是没有 noise source。我们一开始是先用手臂去量它的那个 S 参数，那参数量完之后呢，用我们的 receiver 手臂去做它的那个noise calibration。noise calibration 之后接上 DUT， 然后后面再接一个 terminator， 这边就可以不用了，直接 terminator DUT amplify 就直接量。
之前这个要额外再进行校准，输入的这一段到这边之前。
校准的话是这一段，就是那一颗这一颗 receiver。
没有，那是高频。我说如果低频。
低频的话也是要，就是步骤都是一样的，那只是差在我现在用的是哪一个界面而已。
那我刚刚先量 DUT 的参数。
对，先量 S 参数，然后再做那个 noise calibration， 然后才会接上 DUT 去量。那不管是接这里或接这里或接那里，那个步骤都是一样的。
那我们讲现在我们要进行noise 一个量测试，意思就是说我们还要把module拆掉，在车上装去下车。
对，
那这样就变成我们拆装这个 module 会很麻烦。
拆装 module， 我想一下，那时候
没有，
那时候好像说会做一个漏的去比嘛。为什么问题？
哦，就是我们在量 noise speaker 最后一个步骤不是要上那个50 ohm 的 termination 吗？
对。
那但是在之前我们会一直接到这个 module， 那变成说我们每次量测都要一直进行拆装，去进行那个装漏的。
接到 module，漏的接到 module。
不是，就是
他意思是说，在做那个 noise calibration 的时候，我们只要接 terminator。
那个要在这上装那个 terminator。那可是，在量之前，我们要先接这个 module 做一些量测，然后最后一步才是换成 termination。那变成说，我们要一直在这边做拆装嘛。
This mention is through our demo. In our demo kit, there's a process of connect the termination and disconnect the termination. So for our wafer measurement, do they mean they need to test the termination, then make the measurement? So what is the way to do the calibration?
That is like is the what is problem for the flow station noise finger measurement. That's just one idea. For the like a receiver calibration, it is the composite receiver here, and maybe some cable to the probe chip. Then if the calibrate for some receiver calibration, I think that you know is the attached to the termination of the calibration substrate. Then you can calibrate some like receiver, no, sorry, noise calibration. No, the composite receiver. Then is the here is changed to the DUT. Current termination on the way up. So using another probe chips, and one idea is termination at here, and connect to the DUT output. That is one idea. But its problem for the is the this is loss. Sometimes it's affect to the noise figure value. So we have to compensate for this one, and also we have to calibrate it's receiver side. That is also like difficult to absolute power value to determine at the its receiver inside. How to compensate here? Now it's we is investigating for some idea to compensate or how to calibrate for the probe station. And also, it's another problem. Noise figure is value error is the depend on some like a mismatch between test port and DUT. So omega device is not 50 ohm sometimes. In that case, is DUT's mismatch is big. Then now it's we cannot describe that how much worse than 50 ohm, but I have some like error. Meaning is like some like a ripple or something like that. So that is like another problem. Maybe it's some like compensation. Maybe it's easier to using some like calculation or de-embedding process. But one problem is for the impedance mismatch between the DUT.
Excuse me, do you think at first we calibrate the noise figure through calibration substrate? Yeah, and then I use another port to connect the termination.
Yeah.
And then we calibrate the loss of the port. Yeah, but how about the mismatch between the termination on substrate and termination? Yeah, because actually they are different termination, right?
Yeah. So we have to investigate and have to care for such kind of the mismatch error and how to make a correction of any error is the items. So.
That's a very challenging question. On wafer, sometimes it's not 50 ohm. So for amplifier wafer, you may need tuner, low pool tuner to do the matching.
我想问的是说，就是在量测的时候，它不是做一个步骤，音部要接50欧米漏的嘛？那这个时候我们如果是下针的话，我们后面要接什么？接一个漏的。
对，现在有 customer 在那个针的左边这边针呢，把它去掉，然后就是接个漏的接到那个 probe。
所以我们不需要把它从马球上拆下来吗？
马球上
就是我们讲说我们现在都是走微覆盖的针，那我们需要先把微覆盖的针拆下来，然后装微覆盖的漏，还是说
要装个那个漏是要装到 probe tip 那边？
对，那边就因为我们现在就遇到一个问题说，如果要 cover 波柄段，我们需要用点1的 cable， 如果需要做频繁的拆的时候，点1的 cable 应该是很快就会，每次量测都要这样把点1的 cable 拆下来，然后装漏的上去，那点1的那个 connector 很快就会损坏掉。这是我本来想。
它不是直接装在 probe T 上面就好？
因为客户是直接接在 probe T 上。
直接 probe T 不需要 cable。
对啊，但是你还是要把 probe T 跟 cable
先拆开，然后
再选开啊，那个
对，再选开。
Here, here's the probe tip.
Mhm.
So here, normally they in our demo process, we need to remove here, so connect termination here. Here is the for example, here is a W1 cable. They say disconnect, connect termination. So they feel that the W1 cable connector will get damaged easily.
I know.
Yeah, that's the situation. We cannot.
Because you can always operate without care.
I know. So we have to think how to terminate the input of the DUT.
Yeah.
That is what is problem with. I know. I understand it.
Can we use the termination when calibration about the noise figure? Can we just use another pole and with the terminator and just calibrate it by screw? Yeah.
That is one idea. And yeah, it's a good idea. It's plug them here.
我在用第三个那个灯座，然后专门上那个。
因为那个盘是180度这样，还是要把平常那个手背给拆掉。才可能还是要拆吗？对吧？还是要拆。
我们会把你们设计的不是直接下针。
对啊，但是比较限制使用。
那边是1W1 的1 millimeter
我
wave。
想要说，因为一很容易折断，会不会去做错1.85？
可到1.85你就对，直到65 GHz 啊。
对啊，那假如一操作在780，然后把60进来，这样的做法可以。
不行，它那个 uncertainty， 那 connector 就本身限制了你量测的频率了。
到时候可能那一段
molding 就很多了。
So that is one idea. If they are using the now is compact is the millimeter wave module, then maybe you can set some like a standard positioner on the flat thing, maybe the 2 or 3. Okay. Then one is the probe chip with terminator here. Then is the for the measurement, it's like a chuck is moving to the other probe. And it's the other side, the receiver side, to moving by the positioner. Then attach. That is one idea.
But need to assume the two probes.
One is
exactly the same.
one is for the something like S parameter measurement or it's the calibration for receiver side, and one is only for the termination probe chips. That's it. One idea. I try to memorize and suggestion to the Japanese customer. Good idea.
Because your question is similar to what Japanese customer has said.
I think because due to the mismatch and the loss of the power, I think can we just use because the calibration substrate is through line, right? About maybe 20 micrometer.
Yes.
And the loss is very small.
Yes.
And it's almost 50 ohm.
Yes.
So can we just calibrate by through and this probe with the terminator, and the loss of this probe will be calibrated, right?
Yeah. Yes. I think so.
So I think maybe this measure will occur more accuracy or not.
That is a good idea. For the noise calibration at the composite receiver.
You mean making the termination on the wafer?
No.
Because the initial idea is using the receiver to contact a terminator on substrate, right? And to 100 ohm resistance.
Yes.
Yeah, but when we want to create an input on wafer, we need another pole and with a terminator. Yeah, but this pole will have its loss and it affect the noise figure directly. And this terminator and there are some mismatch between these two terminators also. So I'm wondering if we can just use a through
maybe we can make this two port very close. And this line also a 15 ohm. And now the port 2, the receiver will look into the just like a 15 ohm transmission line connect to a 15 ohm.
That way.
Do you think it's possible?
Yeah, it's a, this is also it's like 100 ohm, 100 ohm. It's the calculated value is 50 ohm.
Serious.
But have some like mismatch. And if they're using the partial type of the termination here, and they're using the 50 ohm screw line. Sometimes it's more is accurate or no, that is 190. So we have to check which is better for the any loss factor or something like that.
And also right now we are working on the create de-embedding embedding for the on wafer measurement. 像我们现在的工程师也在开发说 ，for on wafer measurement 的话，我们要加入一些 embedding、de-embedding 的功能，所以把你的 probe 的一些效应把它去除掉。
可是它如果可以这样弄的话，其实一开始在叫的时候就已经 probe 的效果全部降掉了。
对。
你们加一个 adapter
对。
就是它还是会有一点点距离，会有点相位差。noise 的话应该是绝对的包的。
就说我们最近跟那个源自大学的一个黄建勋黄教授，也是你们的学
老师的学生，
对对同学，那他现在就在开发一个说2 Giga 到110 Giga 的 multiple line 的 TRL solution， 他写成一个软体，直接把这些它是 redundant 的 standard， 用一些多余的一些 standard 在它的校准里面，那它频带就可以覆盖很宽的 TRL。本来 TRL 有频率的限制嘛，它用 multiple line 就造成频率范围很大。
可是 multiple line 不是本来就有？
对，本来是 NIST 的一个 LRL 的一个标准 repeatability 很好。那它现在就用个 TRL， 做精密度会比 LRL 差一点点，但是它的就是说频带范围就是可以 cover 然后重复性会没，所以你可以跟他联络一下，跟黄建勋教授联络一下，看他的那个程式在打 wafer 的车上。可以协助你们的一些 protein 跟相应的话，可以推掉。
做一定可以做，现在就不想搞这个了，就想做，因为什么就多一个 protein， 无论做 sector 服务或者是额外 standard 计算，它就很繁琐，那一天只是1、2个得到一个。所以我们在讲说是比较简易的方法，可以尽快。
这在我们的现在软体正在开发，就是做这种那个wafer 的校准上面的 embedding。其他还没有什么问题，没有的话我们就直接用这个演示，让你看下去。
对，因为我们先看一下或者说还会再说一些题，因为我们现在还没有看过怎么样的状况。那如果 demo 的时候，我们在一些问题上再慢慢。
So they are ready to see the demonstration.
低一点。我说我啦，你们会看不到。
把那个就是 receiver module 接好了。那 receiver module 大概就它只要接 local 跟 test 就好，然后那个从 VNA 出来不用接，它 RF cable 不用接，然后 reference cable 不用接这样。然后接下来就是把 common side receiver 接到我们的那个receiver module 上。
当然就校准前后，这 cable 尽量减少移动。对。
那已经校完了？
还没有。
所以现在是进行校准。
已经校完了，然后我们会直接就是使用那个我们校完的档案，然后去做一个展示这样。
所以我们每次校准都不用再重新校正。如果以这么高的频率的话 ，Did you need recalibrate for every demonstration?
No, so this time we already took the DUT S parameter data before, and also we already is calibrated receiver. So we will use this one.
So it is very insensitive.
So depends on some like is the composite receiver and the VNA stability.
Okay.
So they need to do some like warm up time for the VNA about 1 hour, and for the DUT and such kind of composite receiver. Depends on the amplifier, but need 10 minutes or something like that. If just after turn on the bias, then measure the noise figure. Maybe the DUT is noise figure is a little bit drift by the temperature or something.
So if we measure the noise figure, we only calibrate one time. After this time, we can use this data for every we measure.
And you have to is the calibrate noise calibration. That is must, because the noise is depend on the temperature or something like that. So that is very important. So you have to do noise calibration, but the receiver calibration
only one time.
Is one time.
它条件是那个不能拆，你们的那个 amplifier 跟 filter 不能拆开的。那如果拆开了，你们那个 calibration data 就要再重做一次。那如果你没有拆开，你那 calibration data 是不用重做。
应该每次都要重做。对，所以就是假设你们只要边趴没有拆掉，就不用重做。
对，可是这样如果假设，因为像我们刚刚回到刚刚那个 cover 很多频段，我们光每一次拆就量一个频段就要再重校正一次。
对。
就是我们如果要换，
只要再做一次 receiver calibration file。
所以我们这次刚好就是 cover 一个频段，都不用再重新校正。
对，因为就是已经做好了这样。然后就是在做 noise 量测之前，我们要先量这个的 S parameter， 然后把它存成 S2P file。
它是 DUT 吗？
对 DUT， 但我们都要拿来当代称一样。那你要存 gain 也可以，你就是只存 gain 也可以。你只存，然后你如果4个参数都要存也可以，都可以这样。
可是存更加这样就表示我们不考虑 mismatch 嘛 ，mismatch 的部分就全部吸收到那个对。
他会自己去，因为 application note 是写说要存 gain 或是存4个 S parameter， 他说这样都可以，所以他并没有说非常指定说一定要存什么。
所以他计算的时候只有计算 gain。
不，我觉得这样有点怪怪的。
就是如果有计算 S parameter 的话，
它的 gain 也是要转成 S parameter。
对，但是如果只有 gain 的话，那 mismatch 会更严重。
对，所以现在就要问这点钱。
那个是
S21
It's the using the S21 data only, but it's the and that is it's the reload that's kind of a data. It's from the S2P file format. Because the S2P file format too is the indicating on the header, frequency point or something like that. And where is the S21? Is that I can understand. Then I can easy to pick up on the S21 data.
So in the conversion, the S11 or S22 did not calculate in the noise figure. Only S1 will calculate.
And after we can use that is the S11, S22 data to calculate the uncertainty of the noise figure value. That is uncertainty calculation software that we can provide by the free if you order the noise figure option. that is like create it's like you can use the two ways. One is to check the uncertainty of the noise figure measurement value. You put the gain and some like impedance matching of the DUT, then I calculate some like error is the uncertainty is the area, you know. And also, if you want to make the some like accuracy, you is the already have the some like uncertainty window like a plus minus 0.3 dB for the noise figure measurement. Then you can set such kind of the limit first, then calculate it to light composite receiver gain or something like that. So you can enter the both to check the uncertainty of the actual measurement data. And you can use for that calculator to find out the light composite receiver gain or something like that.
这个是里面会有一个
Okay, I can explain later. So what is I can explain.
那接下来就因为我现在已经切到那个就是不刚 preset 了，所以我们就直接进行 noise figure 量测。就是在 practitioner 里面我们就选 noise figure。那这一边的话，你们要记得选那个就是选 test A， 不然它只有低频而已。然后接下来 noise figure 的话，我们先按 noise figure configuration， 然后我们进来之后，我们先改一下我们之前所叫的频率，这样。然后 point 的话，我把它设成跟我们 receiver kill file 一样。OK， 然后 F bandwidth 是原厂建议是10 kHz 啊。它会影响 noise figure 量测，这个
会还是会吧？
那大概就是都建议取10。
对，大概建议，但是有时候
10以下嘛。
有时候取10，你如果点数很多，10很慢。
对啊，就是那个是时间，就是那个
所以
内建的 digital pattern。
就是看，就是假设你们取100，那它是很就是不是很平稳，就是 smooth， 就是可能就是要取低一点这样。
第一个量测不是 bandwidth 要取越宽越足，跟它应该是跟 spectrum 两 power 的想法，那种。
为什么？
因为哥说的。我记得他跟光分析的 iPhone 相关的。
啊？
在用。
我以为是越窄越好，你说进来 noise 比较低呢。那你那 bandwidth 一宽 noise flow 不是上来？
对啊，它不是把一段频段的 noise 收进来，当做某一个
全部都积分进去啊，不是都这样？
就比较接近，可是用 noise 原来的 iPhone 已经要调最大。
你都用什么？
频宽已经都是调最大，波浪。
调窄，我以为是调窄，因为荡进去、荡下来的时候，那个频宽。是。
But we now is the bandwidth is limited by the 1 megahertz, right? Maybe it's for the noise figure measurement. Some is like noise figure measurement is not enough for that.
所以 code
but code to takes the, it's the wideband data is the, simultaneous. But this is network analyzer is the, measure the, very narrow frequency. Is windows to measure it. Then after its calculation to the some like such kind of wideband noise data. So that is not so it's a little different to the noise figure measurement method for the total source with VNA. A little different. So this is only for the, VNA is noise to signal to noise is noise ratios improvement for this using this is higher bandwidth, not for the noise figure measurement bandwidth.
所以还是10 K 嘛，然后就设10 K 好了。对。然后接下来我们就直接 recall 那个 DUT 的
S prime 的。
所以这个你们之前已经量过了。
对。
这个 DUT 它的特性看一下里面长什么样。
对
这个 S2D
也不能蛮，它是 real linear 的值啊，对，所以因为它是纯4个 S 像素这样，
所以就是你们也是直接就量得出，
对，
也不用太那个，
不用太去，
不用说特地一定只要把 S2 拿出来。
对，它会自己帮你抓这样，然后 OK， 然后我们就直接就抓了。然后量之前要先记得要这样漏的，不然它到时候可能量的时候量一量，再要 calibration 的时候忘记了这样。这个就是 recall 那个 receiver kill file。然后接下来就直接按完成那个 receiver noise calibration。
不好意思，我想问一下，那我怎么知道我 K 完之后，它现在对还是不对？在我还没有量测之前。
How do you know the calibration result is correct? How do you know?
How do we examine the calibration accuracy?
Yeah.
That is a good calculation.
Because sometimes like noise figure analyzer, we can just connect us through and find the noise figure is maybe 0 or just put a 3 dB attenuator and check the noise figure. But how about to using this technique? Okay.
So I think if you want to check the calibration is correct or not, using the some is one is a fixed coaxial attenuator to connect to that. Then the 10 dB attenuator maybe is a 10 dB noise figure.
So we replace the DUT to a 10 dB attenuator to measure the
And see the 10 dB is noise figure value to have the how much ripple or something like that.
We don't have the chip-on-chip attenuator.
I know. or some is a longer calibration substrate is the straight section. Long one.
But we don't have the S parameter of the attenuator, right? So if we want to measure the attenuator, we need measure the S parameter of the attenuator first, right? But so we cannot use one setup to measure two devices. So it's a problem to prove this calibration is correct.
Okay. But the coaxial type, the coaxial is measurement or waveguide measurement can use some like a fixed attenuator to check the accuracy. But all we have measurement, how to test or how to check that calibration accuracy. That is what we have. Well, let us see. Maybe not so good.
就现在我已经把那个 DUT 跟接上漏了，然后接到我们的电路上。然后我们看到我们的那个 noise figure，它的 average 应该在4附近啊，它正不会超过1 dB 这样。
为什么会这样稍微这样动？
是跟温度有关吗？
是
风扇。Why is the curve?
Slide change. Slide change.
That is like some kind of the uncertainty of the or is the some like a stability of the receiver, because the noise is very low power, you know, and this is a vector. It's a network analyzer. It's average noise floor is about 110 dBm minus 110 dBm. But its noise is more, you know, it's lower, maybe minus 140 dB and something like that. Then we are using the preamplifier here. So anyway, we are measuring the very low powers noise then they have some fluctuation. But, so if you want to reduce some like that kind of the fluctuation to set the narrow IF bandwidth, or it's some like change the number of the RMS here. Try to change it to 6,000.
啊，那个要校正前就要做。
哦，没关系，所以
For calibration, right? We need to change it for calibration.
Just 6.
oh,
Not so big, not so big change.
Salt.
I see that a bit.
The load figure is increased
Yeah.
almost 2 dB
Yeah.
right now. So you need to do before the calibration.
Yeah. So do again. 要做一次，再做一次吗？
没关系。
大概。
其实我们是很关心说什么时候比较低可以存起来这样。
可以做个 minima hold 的给你。
Yeah. You should have a function with minimum hold.
Noise figure is very sensitive.
Yeah.
Measurement.
如果一直跳，是的，
对啊，所以我们就一直等在最低点。
一直 hold 忘记。
有没有试着就是说吹冷气不吹冷气的状态？
我有听说半夜4点量最
对，
最
我们有。
大概4点量。
对，
我有听过一个非常有经验的国外工程师强烈建议半夜4点。
不管是 face noise 还是
那个 noise
都有半夜，然后灯都关掉，留那个。
不是在 chamber 里面吗？
没有在那个
无尘室，
然
但它
后天文所那边有一间那个密闭的，
就
他们就是要进去，因为他们外面有一根太大的天线管。
Some of their colleague overseas saying suggested
应该圈门里面应该都隔离起来，应该还好。哦，没有，他那个不是圈门，他那个是为了要，他那个是一开始发现他室外有一只大天线，然后 FN，然后他们还会有影响，对，他们还特别做一间密闭室在那边。他一开始不是圈门。
应该在 chamber 里面
有那个天文所有圈粉，
在里面不舒服啊，空气不流。
而且它没有 probe station， 它只能量8.9。
是两样拆装大工程。
对啊，尤其是要
你们有办法那个一只手臂上装2只这个啊？没有办法。
一只手臂装2个模块，
飘动度 OK 吗？
应该还 OK 的。
Change the dimension.
对，你知道。